Good day, brave warriors. Last video, and then we finish all our work for prelims. I know I put you under a bit of pressure, but it means we're going to have time to consolidate for finals, which is often not the case. So we should have read through page 277 to 287 of your textbook, plus the summary at the end of the chapter. Okay, if you haven't done that, press pause and go do that now. Otherwise, you're going to be wasting your time with it. Okay. So, just to quickly run through a couple of things. So, guys, the key idea with probability density functions is that it's for a continuous random variable, like a normal distribution. And unlike with the probability mass functions, where you could read off the probability, okay, to find the actual probability is not a value, it's an area. And if it's a probability density function within the defined domain, that area must be equal to 1, because all the sum of the remember, an integral means an infinite sum, okay, infinite number of divisions within that area, okay. So the integral between 1 and 3, if this is a probability mass function, must be equal to 1. Remember, when you're finding the textbook wastes a lot of times, when you're finding definite integrals, use your calculator. Okay, and if this was another probability density function, the integral must be equal to 1 between 0 and 2 in the defined domain. So that to find the areas, you're finding integrals. Just one thing that's a bit confusing though is the mode. Okay, you're going to look at the mode. The mode is going to be we find the x value for the mode. We don't find the actual mode. Okay, where the mode is the most frequently occurring thing, and the most frequently occurring thing will be at the maximum value. So here it will be x is equal to 1. Here it will be at x is equal to 2. And if you've got a function that changes whatever, it will be at the turning point. That'll be your mode. Okay, median is going to be where the area is in half. Okay, mean is the expected value x times f of x. Okay. So the condition for probability density function, it's got to be continuous. You can only have positive y values, okay, because your probabilities can't be negative. Remember, f of x represents probabilities, and in the required domain between a and b, okay, all the sum of the probabilities must be equal to 1, because remember that means infinite sum. So then, okay, I'm not going to go through all the examples with you. You should have done it yourself. Okay, I'm going to go straight to just one thing about the median. Okay. When you go find the median, okay, the median is the thing that's in the middle. So half, the probability to the left must be a half, the probability to the right must be a half. So that's your principal median. From where you started to m, okay, of the function, that area must be equal to half. That's where your median score, okay, will be. So this is the only time when you find the median that you're not going to be able to use the calculator integral mode on your calculator. Okay. Always you're going to use the calculator though. Just one thing with the mode. The mode, okay, is where it reaches its maximum value. So in a case like this, that would be the mode. That would be the that would be the mode over there. It's the turning point. So that if there's no turning point, okay, it's where the maximum value happens. So you have to sometimes sub in the endpoints, okay, or you have to sub in. If it's a curved function, you have to, how do I find a maximum value? It's where the derivative of the probability function is equal to 0. Okay, just remember, on your formula sheet, you've got a formula for the mean of a probability mass function, which is sigma x times probability of x is equal to x. I would write this one in as well. For a continuous function, ex is, or instead of, it's an infinite sum, is an integral of x times the probabilities, which are f of x. So that's your formula. Okay, it's not given on your formula sheet. You need to know that. That's for your mean of a probability density function, or else the expected value. Okay, it's x times f of x. Infinite sum is an integral. Okay, right. So that's on your formula sheet. Okay, and we're going to do exercise 2 on page 288. And we're going to start with question 4, which says the probability function is given by the following. Gives you that whole speech. It says show k is equal to 1 over 12. I just want to make an A2 there, and I want you to sketch f. Okay, just do one sketch, then find the mean, median, and mode. Okay, so let's get cracking with that. So question, well, sorry about that. Okay. Okay. Question 4. Okay. Not 3. Okay. 4, 5, 6, and 9. Right. Question 4 says f of x is equal to k 9 minus 2x. Okay. When x lies between 1 and 4 and naught elsewhere or otherwise. First question says show that k is equal to 1 over 12. Okay. So the key idea, okay, is that within this interval, okay, you've got some graph over here. It's defined between 1 and 4. So the key idea for finding it, just like it was with probability mass functions, the key idea where we said the sum of sigma of the sum of the probabilities must be equal to 1. Here, the sum we write as an integral. So the integral from 1 to 4 of f of x must be equal to 1. In other words, okay, the sum of the probabilities is the infinite sum of the probabilities is equal to 1. The probability density, okay, must sum up to 1. So here, in this case, f of x is, so I'm looking for the integral between 1 and 4 of k 9 minus 2x. Okay, integral between 1 and 4 of k 9 minus 2x with respect to x. So x is a variable. So what can I do? I can remove the constant. So that, is equal to 1. Okay, so sigma f of x is equal to 1. So that is equal to 1. So therefore, I can take out the k. K times the integral between 1 and 4 of 9 minus 2x with respect to x is equal to 1. I'm going to go up here. Okay. So this bit over here, the integral between 1 and 4 of 9 minus 2x, okay, we can work that out on our calculator. So k times whatever our calculator gives us is going to be equal to 1. So you're going to go the integral, okay, of what function? 9 minus 2x, 9 minus 2x, okay, between 1 and 4 equals, okay, and you get an answer of 12, right? So k times 12 is equal to 1. You don't have to go through what the textbook does and show all that other crap. So k is equal to 1 over 12, which is what I was asked to prove. Okay, so please use your calculators. Right, the next thing it says sketch the graph. Well, now the function has become f of x is equal to, I could rewrite it as f of x is equal to 9 over 12, because k is 1 over 12, minus 2 over 12, which is minus a 6x. So f of x is equal to 9 over 12. Am I right? 1 over 12, 9 over 12, minus 2 over 12, minus a 6x between 1 and a 4. Okay? So this is a straight line. If I did the probability, so all you have to do, you've got a straight line with a negative gradient. Okay? It's defined between 1 and 4. So there's 1, there's 4. Okay? When x is equal to 1, the probability f of 1 will be 9 over 12 minus 1 over 6. And 9 over 12 minus 1 over 6 is 9 over 12 minus 2 over 12, which is 7 over 12. So when x is 1, the probability is 7 over 12. So that is in line with 7 over 12. Okay, it's a straight line graph, okay, with a gradient of negative 6. Okay, so we know it's going to be a straight line. So, and the final point will be at 4. So f of 4 will be 9 over 12 minus 4 over 6 if I replace x with 4, which is 9 over 12 minus 8 over 12, which is 1 over 12. Okay, so 4 is in line with 1 over 12. So this, okay, is what the probability mass function looks like, right? Okay, and you'd have to have, okay, in that area over here, okay, the area of the shaded region, okay, this area over here, I'm just checking something, okay, would have to be equal to, so if you drop it there, drop it there, so that whole area over there, that's the principle used in order to answer this question. That area must be equal to the sum of this whole area over here using integration must be equal to 1. So there's your graph. Okay, that's the graph of f. Okay, right. Then the next question says, go find the mean. So when you're asked to find the mean, if you forget, go to your formula sheet. Okay, remember, it's the expected value. It means often ask for find the expected value. So it's x times the probability value. Okay, sum them all up. So the formula, okay, is e of x. And you know this formula is equal to the sum of x times f of x, where f of x is your probabilities. So in our particular case, e of x is going to be equal to the sum from where to where? Okay, from 1 to 4 of x times by, well, f of x is equal to 9 over 12 minus a 6x with respect to x. If we simplify that up, it's the integral between 1 and 4 of 9x over 12 minus x squared over 6 with respect to x. Okay, integral between 1 and 4 of 9x over 12 minus x squared over 6 with respect to x. It's a definite integral, so I can use my calculator. So I go the integral between 1 and 4 times it by x. So it's the integral between of 9x over 12. So integral of 9 alpha x over 12 minus x squared over 12 alpha x squared over 12 between where? Between 1 and 4 equals, and we wait, and you get an answer of 31 over 8, which is approximately 3, well, it is equal to 3,875. So that is your expected value, okay, which is at 3,875. I just want to check that. Something doesn't sit comfortable with me. Might be. So I'm just checking the memo. I made a mistake somewhere. Right. So it became 12. You should get an answer of 2. I thought it was wrong because the expected value should be round about here. Okay. So I said x times 9 over 12. 1 over 12 x times 9 over 12 minus a 6x, which is going to be 9x over 12 minus x squared over 6 between 1 and 4. So I'm just checking in the memo. I don't know why this is not giving us the right answer. So, they took out a 12th. If you took out a 12th, I'm trying to see something. You'd be left with the integral between 1 and 4, okay, of 9x, because that'll be 2 over 12, 2 over 12x, okay, so it'll be 9x minus 2x squared. And did that have that function? What did I get? 9x minus 2x squared. Yeah, I'm right. I should be right. So if we take out a 12, we'll have a 12th. Okay, sorry. So if we took out a constant, it shouldn't make a difference. Okay, you'd have a 12th integral between 1 and 4, okay, of 9x minus 2x squared. Yeah, that's what they had as well. Okay, with respect to x. Okay, which is 9x over 12. Ah, man. This should have been, my mistake was here. Sorry, guys. My mistake was minus x squared over, it wasn't over 12 in the question. Okay, this should have been over 6, because it was minus 2x squared over, it was minus x squared over 6. Let's check that with respect to x. And you get 17 over 8. Sorry, I was right. Okay, I just entered the wrong thing on my calculator. So it was minus, you could have left it like this, 9 over 12 minus x over 6 with respect to x. So you should get an answer, okay, whichever way you did it, whether you took out the constant or not, of 17 over 8, which is approximately 2,125. Sorry, just put it, I put x over, all I did was I put x over 12 instead of x over 6 in your calculator. So you should get an answer of 17 over 8, which is 2,125. Right. The next thing says, go find the median. Okay. So to find the median, well, the median is where you want, if you looked at this graph, okay, the point where you want the half of the area to be to the left. Okay, we're looking for the x value where half of the area is to the left. Let's call this value m, and the other half is to the right. So we want that area to be 0,5. Okay, that's going to be your median score, your score in the middle. Okay, so that yellow area must be 0,5. How do I describe that yellow area? Well, it's the integral between 1 and starting from 1 going to m of our function. Okay, our function is, I'm going to take out a 12th, prettier. A 12th, don't have to though. Okay, take out a 12th and you're left with 9x minus 2x squared with respect to x. Okay, so you get a 12th between 1 and m of 9 minus 2x, 9x minus 2x squared. Okay. Oh, good night, man. I'm having a bad day. Okay, the median is a 12th integral between 1 and m of the function with respect to x. The function is not the one of the x squared. The function is this over here, 9 over 12 minus 1 over 6x. Okay, so it's going to be the integral between 1 and m of f of x with respect to x, which is the integral between 1 and m. F of x is 9 over 12 minus, no, I did f of x times x, minus 1 over 6x with respect to x. If we take out a 12th, it's going to be a 12th, to make it prettier, integral between 1 and m of 9 minus 2x with respect to x. Okay. The 12th integral between 1 and m of 9 minus 2x with respect to x. Yeah. Okay. Right. And the key idea is that this area must be equal to a half. Okay. So this area, the integral between 1 and m, 9 over 12 minus 6x, must be equal to a half. So this is equal to a half. Right. So you're going to have to do this manually now. So median is the only time I can't use your calculator. Okay. So it's going to be the integral of 9 minus 2x is 9x minus x squared between 1 and m must be equal to 0,5. Okay. So if I sub in m, I get a 12th 9m minus m squared. That's after I've subbed in m. Now I've got to sub in 1, will be 9 minus 1 is equal to 0,5. Okay. If I go simplify that, I get 9m. Okay, so this all should be times by a 12. Let's get rid of the 12 at the bottom. So I get 9m minus m squared minus 8 is equal to 0,5 times 12, and 0.5 times 12 is equal to 6. 0.5 times 12 is 6. Okay, so I end up with a quadratic, and the quadratic is 0 is equal to m squared minus 9m plus 14, and if you factorize that, you get 0 is equal to m minus 7, m minus 2. Okay, so m is equal to 7 or m is equal to 2. Okay, but we can see from our graph, okay, that the median can't be at 7. That's outside the required interval. So the median, in fact, must be at 2. Right. So your median is equal to 2. Okay. Right. So that is the median. Okay. Right. Whew. Okay. So there's your median. Right. The next question was what? Okay. Go find the mode. Now for the mode, okay, what did we say the mode is? The mode is the highest point on the graph, the turning point, maximum value on the graph. So you can see this is a straight line graph. So for the mode, you're not going to have to go find where the derivative is naught. The mode is simply going to be, okay, at the maximum point. So the mode occurs is at x is equal to 1. So that's the most frequently occurring thing. The mode occurs at x is equal to 1. Right. So that was for that one over there. Okay, we got those all right. So a reminder, so the mean, okay, is the formula for the mean you need to know. It's x times f of x in the required interval. I made a bit of a hash there. Okay, the median, okay, what's the key idea with the median? The area to the left must be 0,5. So that must be 0,5. Okay, and with the mode, it's the highest point on the curve, which is at x is equal to 1. Okay, so that's question 4 done. Okay, question 5. Okay, you've got f of x is equal to k, 3x squared minus x cubed between 0 and 3. And then it's equal to naught elsewhere. Oh, yeah, I'm nearly done. Okay, right, the first question is, I'm not popular here. Okay, show that k is equal to 4 over 27. Okay, so your key idea is that if you have a curve, what has to happen? The area in the interval must be equal to 1. How do I find that area for a continuous function? It's the integral. So I must know that the integral, the key idea is that the integral between 0 and 3 of f of x must add up to 1. Okay, and f of x, so in other words, the integral between 0 and 3 of k 3x squared minus x cubed must be equal to 1. So therefore, k times the integral between 0 and 3 of 3x squared minus x cubed must be equal to 1. Okay, but this thing over here, you don't have to do what the textbook does and work that out on your calculator. Manually, you can shove that into your calculator. So you're going to go the integral between 0 and 3 of, it's okay, you've got to do it the other way around, sorry. The integral of 3x squared minus x cubed between where and where? Between 0 and 3. Okay, let's shove that into my calculator. I get an answer of 27 over 4. So k times 27 over 4 is equal to 1. Divide that out, you get k is equal to 4 over 27, which is what we were supposed to get. Okay. Right, B says find the mode. In other words, the maximum value of f. So the mode, here we're going to have a function. Okay, we can't really visualize the function, but we know that the function is of the form f of x is equal to 4 over 27 times 3x squared minus x cubed. Okay, we can make that prettier, and it becomes f of x is equal to 12 over 27. Okay, 12 over 27 x squared minus 4 over 27 x cubed. Okay, between 0 and 3. So now the mode is going to occur. Remember, the mode is where the maximum value occurs. So I need to find where that derivative is equal to 0. So the mode will be where f dashed of x is equal to 0. So in other words, where 24 over 27 x minus 12 over 27 x squared is equal to 0. We can get rid of the constants. Times by 27, you get 24x minus 12x squared is equal to 0. Divide by 12, 2x minus x squared is equal to 0, which gives us x. 2 minus x is 0, so x is 0 or x is 2. Okay, and when x is 0, then f of x is equal to 0, so the probability is 0. So the maximum must occur when x is equal to 2. So the mode happens at x is equal to 2. Okay, right, 2 sums to go, and we finished for prelims. Right. Now the next question, you've got a question about a rocket. It says, it's given that the probability density function of the distance x in meters that a missile falls from the intended target is f of x is equal to kx minus 3. X is the distance, how far away, how much it misses by, naught elsewhere. First question, show that k is equal to negative 2 over 9. So what's the key idea? That the sum of the probabilities is 1. A sum is an integral. So we want to show, so we're going to use the fact that the integral between 0 and 3 of kx minus 3 is equal to 1. I mean, it would be pretty easy to do this manually, but you're always in a rush. So you're going to have k times the integral between 0 and 3 of x minus 3 is equal to 1. We can figure this out on your calculator. Okay. Lob that into your calculator. So I get k integral between 0 and 3 of x minus 1. Okay, integral between, so I'm looking for integral of x minus 3. Okay, between 0 and 3 equals negative 9 over 2. So k times negative 9 over 2 is equal to 1. So therefore, I divide by negative 9 over 2. Okay, it's the same thing as timesing by 2 over negative 9. So k is equal to negative 2 over 9. Right. Now the next question says, find the probability that the missile will fall within 1 meters of the target. Well, x is the distance the missile misses the target from. So we want to find the area, the probability of the area, okay, but it must between 0 and 1. Okay, that'll represent, okay, the probability that it falls between 0 and 1. In other words, less than 1 away from the target. Okay, we know that k is equal to negative 2 over 9. So the function is negative 2 over 9, okay, times x minus 3. So that's what we're looking to find. So it's going to be equal to negative 2 over 9, integral between 0 and 1 of x minus 3, okay, which is going to be equal to negative 2 over 9. Show that into your calculator, or you can work it out manually. Okay, integral between 0 and 1. Okay, so it's the same thing here, but just up to 1. So integral between 0 and 1 of x minus 3 is negative 5 over 2. Okay, so that's fine. Okay, I panicked because I thought, how can I get a negative answer? But I can't because I've got to times it by negative 2 over 9. So the 2's cancel and you're left with an answer of 5 over 9. So there's a 5 and 9. Okay, it's quite a good missile. And over 50% chance that the missile will fall within 1 meter of its target. Okay, then it says go find the median distance away from the target. Well, if I think of it, just a picture in your head. Okay, I don't know what this graph really looks like. Oh, it's a straight line graph, isn't it? Okay, with a negative gradient. Okay, so the median, okay, is negative 2 over 9. The median is going to be halfway. Okay, so I want this area to the left. Remember the key idea, where does the median, I'm going to call that value m, that's the median value. And the median value happens when that area is 0,5. Whoa. Just had a washing line accident here. This is going to be, it's going to get hectic here now. The washing has been injured, fallen over in the wind. Okay, Amron thinks it's funny. Dale is about to jump off a cliff. Right, okay. So, Roger's just trying to keep a low profile, which is not very good when you're talking all the time. Okay. Family are about to kill me because of you guys. I'm just warning you. Okay. All they see is me speaking to a screen. So, we're using the principle that the integral between 0 and m of the function, we want to know where that integral and the function is negative 2 over 9 x minus 3. Okay. That we want to know what m is, so that the area is 0,5. Constant suck, so let's get rid of it. So it's negative 2/9 between 0 and m of x minus 3 with respect to x. That must be 0,5. Okay, we're going to have to, median, you're going to have to find the integral manually because you've got a variable. So it's going to be negative 2/9. Okay, the integral is going to be x squared over 2 minus 3x between 0 and m, but that must be equal to 0,5. Okay, so I've got negative 2/9 all times by subbing m squared over 2, okay, minus 3m. If I sub in 0, it just becomes minus 0, okay, and that must be equal to 0,5. I'm going up here, so I get negative 2/9, okay, m squared over 2, okay, minus 3m is equal to 0,5. So I'm going to have times by 9, I'm going to have minus 2, okay, m squared minus 3m is equal to 0,5 times 9. 0.5 times 9 is 4,5. So that's equal to 4,5. Divide by negative 2. Okay, to get rid of that other constant. And I get negative 9 over 4, or negative 2,25. So I get m squared minus 3m plus 2,25. Might have made a careless mistake somewhere. Is equal to 0. Probably can't see a thing. M squared minus 3m plus 2,25 is equal to 0. So guys, never use a quadratic formula in AP. Always use your calculator. Okay, let's just check if we're on the right track. Which is the same thing as m squared minus 3m. Okay, let's just check. Okay. Minus 2/9. M squared over 2 minus 3m is equal to 0,5. Yeah, I'm on the right track, I think. I've done slightly differently, but if I go mode, equation, quadratic, a is equal to 1, b is equal to negative 3, c is equal to 2.25, equals, you get 3/2. No, I've made some mistake here. Okay. Anyway, somewhere went wrong. Okay, you can check your memo. Okay, the principle is right up to here. Okay, you get negative 2/9 m squared minus 3m is equal to 0,5. I don't like being wrong. Okay, so 0.5 divided by negative 2/9. Let's just check. Okay, mode 1, 0.5 divided by negative 2/9 is equal to negative 2,25. I am right. Okay, negative 2/9. Oh no, here's my mistake. It should have been negative 2/9 m squared over 2. I left this 2 out. Okay, is equal to just the washing. Negative 2/9 m squared over 2. Sorry, I left out this 2 over here. Okay. So I end up, if I divide by negative 2/9 with m squared over 2 minus 3m is equal to negative 2,25. Let's times everything by 2. So you get m squared minus 6m is equal to times by 2, negative 4,5. So you get m squared minus 6m plus 4,5 is equal to 0. And if we solve that using our calculator, we're going to go mode 1 equation, m is 1, okay, 1 equals minus 6 equals 4.5 equals, yay, I'm right. So I get m is equal to 5,12, but 5,12 is not applicable, okay, because we're only looking in that interval. And I get 0,888, let's say. M is equal to 0,88. So there's your answer. Your median is at 0.88. Okay, that's going to be where we're working from. Sorry about the careless error, I just left out that 2. Right, last sum of the term. Okay, the question says, guys, it's trig, so you've got to be in radian mode. You've got the function k cos x between 0 and 2. First question, show that k is equal to 1. So just don't be, all I did is this one because I want you, key idea is that the integral between 0 and pi by 2, the sum of the probabilities in the required area of k cos x must be equal to 1. So k times the integral between 0 and pi by 2 of cos x is equal to 1. This we can just chuck into our calculator. Okay, so I get k, I mean, it's pretty easy to do manually. Okay, the integral. Okay, you've got to make sure you calculate it in radian modes. The integral between 0 and pi by 2 of what function? Of cos x between 0 and pi by 2. Be a nice number. Okay, calculator's taking its time, is equal to 1. So you get k times 1 is equal to 1. So k is equal to 1 as required. The expected value, how else could we ask this question? Go find the mean. Okay, your calculator says you must do parts, but we can use our calculator, dumbasses. So the mean, the formula is the integral of x times f of x. Okay, to find the mean. Okay, that's our principle that we're going to use. Okay, the mean is the sum of all the x times the probabilities. So in this case, it's between 0 and pi by 2 of x times f of x, which is just cos x, because k is 1, with respect to x. So we just chuck that into your calculator. So it's integral between 0 and pi by 2. In fact, I can just go back here and just shove in an extra x. Okay, of alpha x times cos x with respect to x. And that should work. And we wait for our calculator, and you should get 0, question 9. Okay, you should get an answer, which they took about a week to do, because they went and did it manually, but of 0.5708. Right, and then the last time, go find the median. Okay, so to find the median, what's the key idea? The median occurs when half is the area to the left is equal to 0.5. So in this case, okay, we call m the median. We're looking for the integral between 0 and m of cos x, okay, with respect to x. We want to know where that's equal to 0.5. We're going to have to do median manually always. Okay, so the integral, so we're looking for the integral between 0 and m. We know that's 0.5. What do you have to differentiate to get to cos? Sine x. So we end up with sine m minus sine 0 is equal to 0.5. So sine m, sine of 0 is 0. So sine of m is equal to 0.5. To find the angle m, okay, you're going to go shift sine to the -1 of 0.5. And we're going to get equal to pi by 6, which is in the interval required. Pi by 6 lies between 0 and pi by 2. So m is equal to pi by 6. That is your median value. Okay, sorry for the odd areas. There's quite a bit going on. Okay, and we are done. Okay, practice if you've got time. Exercise 2, number 3, 7, 11, and 12. But we have done quite a lot, so you should be fine. All the work is finished for the prelims. Goodbye. Say goodbye, please. Bye.